Good morning, good afternoon, good evening, or good night, depending on when you are viewing this. Welcome to Chapter 1, Introduction to Statistics. I know that many of you might not have chosen this as your first pick. Let's be real. No one typically picks statistics because it sounds like a fun elective. I also understand that many of you might be feeling a bit anxious about what lies ahead. But here's one thing. While statistics can seem intimidating at first, it's often more manageable and even more enjoyable than we expect. So I want to reassure you, with the right approach, this class will likely be easier and maybe even less painful than you think. So, statistics isn't just about numbers. It's about making sense of data. In simple terms, statistics helps us organize and summarize information. It allows us to draw conclusions based on collecting data. So our goal, to make sure these conclusions are accurate and meaningful using standardized procedures. This means that we can trust the results of studies and apply them to real-life situations with confidence. So when we look at the difference between population and samples, we have to understand that when studying people, we have two key groups, the population and the sample. The population includes every individual of interest, but studying every single person is often impossible. Instead, we select a sample. This is a smaller group that represents the population. If we do it right, our sample can tell us a lot about the entire population. Think of it like tasting a spoonful of soup. You didn't need to drink the whole pot just to know what it tastes like. Ever notice how people are different? Some are tall, some are short, some love pineapple on pizza, which is a crime, and others, well, they just don't. These differences are called variables. Characteristics that change from one person to the next. When we measure variables, we collect data. Now, a data is measurements or observation of that variable. A data set is a collection of measurements, and a single piece of data is called a datum or raw score. Now we're going to move on to perimeters and statistics. Here's a key distinction. A perimeter describes a population, while a statistic describes a sample. So for example, if we surveyed every student in the world, the average height would be the perimeter because we are looking at the entire population. But if we only surveyed 100 students and calculated their average height, that number would be a statistic. Since samples are easier to study than the entire population, statistics help us estimate perimeters. There are two main branches of statistics. We have descriptive statistics and inferential statistics. Descriptive statistics summarize and organize data, like calculating averages or creating graphs. Inferential statistics, on the other hand, help us make predictions and draw conclusions from a sample about the population. So, for example, if a political poll finds that 72% of a sample favors a candidate, inferential statistics help us estimate the true percentage of all voters. Now, no sample is perfect, and it is never identical to the full population. There's always going to be some sampling error. Now, this is a natural discrepancy between a sample statistic and the actual population perimeter. So, for example, if a poll says a candidate has 48% support with a margin of error at plus 3%, that means that the true support is likely between 45% and 51%. So, if you notice, when we look at things or we hear things on the news regarding a candidate who might have support, they're always going to give a +3 or -3 or a +4 and -4 because we have to look at what the true support actually is. And that's with anything. So, science relies on empirical evidence, meaning we gather data through observation and measurement. When we measure something, we need a clear process so that everyone understands what we mean. This is why we use operational definitions, which specify exactly how variables are measured. For example, happiness could be measured through a survey score, heart rate, or even a number of times someone smiles. We have to make sure that we are using the correct operational definition. So if we wanted to, for example, measure happiness through heart rate, then that would be our operational definition. Someone else might use a survey to do that, or the number of times someone smiles. All of these would give different data. This is when we look at the constructs, so the internal attributes or characteristics that cannot be directly observed. And these are useful for describing and explaining behavior. And again, we talked about that operational definition. So using the results as measured both by definition and measurement of a hypothetical construct. Not all variables are created equal. Some are discrete, meaning they have separate, distinct categories. Think of this like the number of pets you own. You can't have 2.5 cats. Others are continuous, meaning they take on a value within a range. So look at it like height. You can be 5'7", 5'7.1", or even 5'7.05". Continuous variables are often rounded, but in reality, they have indefinite possible values. So remember, when we're talking about discrete variables, think of it as you can't have 2.5 cats. It's like the old saying about having, the white picket fence, the American dream, 2.5 kids. Well, you can't have 2.5 kids. You have 2 kids or you have 3 kids. So that's a discrete variable. But continuous variables, again, like height. You can be 7 feet 1 inches. You can be 5'7". You could be 5'10". So those are the differences between discrete variables and continuous variables. So this is just an example of a continuous measurement. Looking at it on a graph. As you can see, we have 439.5. 150 is kind of that middle, 150.5. But again, continuous measurements, it can be 149.6 or 150.3. Now we're going to talk about real limits of continuous value variables. Sorry about that. Real limits are the boundaries of intervals for scores that are represented on a continuous number line. The real limit separates two adjacent scores, and it's located exactly halfway between those two scores. Each score has two real limits. The upper score marks the top of the interval, and the lower score marks the bottom. Now we're going to talk about the scale of measurements. Different types of data require different types of scales of measurement. We have a nomial scale, and this is a category with no order. So think of hair color: brown, blonde, black. Ordinal, these are categories with a meaningful order, but no consistent difference. So think of being ranked in a race, first, second, or third place. So as you can see, the difference between the nominal, which is just categories with no order. Ordinal has an order, but there's no consistent difference. Interval, these are ordered categories with equal spacing, but no true zero. So think of temperature. 0 degrees Celsius, there isn't an absence of heat, it's just not there. And then we have ratio. So like an interval, but this one has a true 0 point. So think of weight. 0 pounds mean that there's no weight at all. So the difference between an interval and a ratio is, again, an interval, think of a thermometer. When you hit 0 Celsius, it isn't the absence of heat. But a ratio is like weight. 0 pounds means that there is no weight at all. Now, here's just some examples. It gives you kind of a good overview of characteristics and then examples. So again, nomial, there's labels and categories, but there really isn't an order. So we have gender, diagnosis, experiment, control. Ordinal, again, these have a meaningful order, but there's no constant. So your rank in class, clothing sizes, medals. Interval, they have an ordered category with equal spacing, but there's no true zero. So temperature, IQ, golf scores, above par, below par. I'm not a golfer, so. And then ratio. This one is like intervals, but it does have a true zero. So the number of correct answers, time to complete a task, weight gain, weight loss, etc. Sometimes we want to know if two things are related. That's where correlation research comes in. We measure two variables for each participant and see if they move together. So, for example, if we would ask, is there a relationship between study time and test scores? A strong correlation means that they're linked, but please remember that correlation does not equal causation. Just because ice cream sales and shark attacks both increase in the summer does not mean that ice cream causes shark attacks. So we always want to look at the relationship between two variables. Two or more variables are observed and measured in order to determine the relationship. This resulting measurement can be classified into two distinct data structures that are used to determine the type of relationship and if it exists. So this is what we were talking about with the correlation method. One group of participants, measure of two variables for each participant. The goal is to describe type and magnitude of relationship. and the patterns in the data reveal that relationship. And this would be a non-experimental method of study. So this is one group with two variables measured for each individual, and this would be the correlation method. We would be looking at Facebook time and academic performance, and looking at all of the students and seeing where, if there is a correlation for how much time you spend on Facebook and how it affects your academic performance. Now, there are limitations to the correlation method. It can demonstrate the existence of a relationship between two variables, but it does not provide an explanation for that relationship. Most importantly, it does not demonstrate the cause and effect relationship between those two variables. So the third data structure would be experimental and non-experimental methods. If we want to prove cause and effect, we need to have an experiment. In an experiment, we manipulate an independent variable and measure how it affects a dependent variable. We also use a controlled group to ensure that nothing else is influencing the results. So, for example, if we're testing a new study technique, we randomly assign students to two groups, one using the new method and one using a traditional method, so we can compare their test scores. This is also how you would compare two or more groups of scores with the experimental and non-experimental methods. This is just kind of a picture for you to look at to understand this in a more graphic way. So the first variable is the type of video game is used to define the groups. And then the second variable would be aggressive behavior to measure, and it would be measured to obtain the score within that group. So again, when we are looking at the experimental methods, we are looking to look at the goal. So looking at the cause and effect, we are going to end up manipulating one variable to determine if it is the cause of the other one. And we do need that control to make sure that we have a base. So getting a little bit more into what an independent variable is, this is the variable that is manipulated by the researcher. Independent because no other variable in the study influences its values. It is manipulated prior to observing the dependent variable. So this variable is manipulated by the researcher. The dependent variable is the one that the observer assesses the effect of treatment. Okay, so it is dependent because its value is thought to depend on the value of the independent variable. So when we need to make sure that we have control conditions in experiments, because these make our results reliable. There are three main ways to do this. Making sure that we have a random assignment of subjects. This makes sure the participants are randomly placed in groups. Matching, ensuring both groups have similar characteristics, so same number of high and low achievers if we were looking at, let's say, test scores. And making sure that we are holding variables constant, keeping other factors like room temperature or time of day the same for everyone. So that would be making sure that we are controlling those conditions, not just for the participants, but also for the environment as well. So not all studies can be true experiments. Sometimes we have to use non-experimental methods. So when we look at non-equivalent groups, these are comparing groups that weren't randomly assigned. So comparing two different schools. And then we also have the pre-test, post-test. So measuring the same group twice before and after treatment. So testing students before and after a semester of a new teaching technique. But these methods can't be proven, they cannot prove cause and effect as well as true experiments. So again, this is just a visual representation of two examples of non-experimental studies. Statistics has its own shorthand. Appendix A of our textbook has a mathematical review that we have gone over previously, but we also use some statistical and specific notations. X and sometimes Y represents individual scores. Uppercase N is the number of scores in a population, while lowercase n is for a sample. The Greek letter E, so sigma, means sum up. So if we had a sigma x, meaning add up all the x values. So I want us to work together. And what I'm going to do is I'm just going to read these out, and then I want you, although I cannot hear you, I want you to think about them. I'll leave a few moments. But a researcher is investigating the effectiveness of a treatment for adolescent boys who are taking medication for depression. A group of 30 boys is selected, and half receive the new treatment in addition to their medication, and the other half continue to take their medication without any treatment. For this study, I want you to identify the population and identify the sample. So I want you to think for a second, who is the population in this study and who or what is the sample? You should have like Jeopardy music. Okay, so if you said the population is the entire group of adolescent boys taking the medication for depression, this includes all the boys in the category, not just the ones selected for the study, you would be correct. So remember, the population is everybody. So the entire group of adolescent boys taking medication for depression, not just these 30 boys. Now, if you said for the sample it was the 30 boys selected, then you would be correct. A sample is a subset of the population used to draw that conclusion. So, bravo! Let's go to number 2. I want you to define population, sample, perimeter, and statistic. This one should be a little bit easier because we just talked about population and sample. Give you a couple seconds. All right, so the population, remember, is the complete set of individuals or elements being studied. All adolescent boys taking depression medication. Now, the sample, a subset of the population used to represent the entire group. So that would be the 30 boys selected in the previous example. A perimeter is a numerical value describing a characteristic of the population. So, for example, the actual average depression score of all adolescent boys taking the medication. And the statistic of that would be the numerical value describing the characteristic of a sample. So the average depression score of the 30 boys in the study. I know you guys got this. I know you're doing great. Okay. Statistical methods are classified in two major categories, descriptive and inferential. So I would like for you to describe the general purpose for the statistical methods in each category. Okay? I know you can do it. I know you might have to look back at the PowerPoint, but these are things that are important to kind of have on top of mind or top of notes. So for descriptive statistic, these are methods used to summarize, organize, and simplify data. So for example, the mean or the average, standard deviation, frequency tables, and graphs. Inferential statistics, these are methods used to make conclusions about a population based on a sample. So when we look at things like hypothesis testing, regression analysis, things like that. Okay. Knight and Halsman found that office workers who had some input in the design of their office space were more productive and had higher well-being compared to workers for whom the office design was completely controlled by an office manager. I would like for you to identify the independent variable and the dependent variable. So, for this study, the independent variable would be the office space, the thing that is able to be manipulated. And the dependent variable would be the higher well-being. So, two researchers are both interested in determining whether a large dose of vitamin C can help prevent the common cold. Each obtained a sample of 20 college students. So, the first researcher interviews each student to determine whether they routinely take a vitamin C supplement. The researcher then records the number of colds each individual gets during the winter. Is this an experimental or a non-experimental study? So this one would be a non-experimental study. The researcher just asks the students if they take vitamin D regularly and then records how many colds they get. So the reason why this is non-experimental is because the researcher does not manipulate the independent variable, which would be vitamin C usage. There's no random assignment, And the correlation may exist, but causation cannot be determined. So for the second question, or the second researcher separates the students into two roughly equivalent groups. The student in one group are given a daily multivitamin containing a large amount of vitamin C, and the other group gets a multivitamin with no vitamin C. The researcher then records the number of colds each individual gets during the winter. Would this be experimental or non-experimental? So this is completely different than the first one, right? And this would be an experimental study because one group is receiving the vitamin C while the other group is receiving a placebo, no vitamin C. It's still a multivitamin, but it doesn't have any vitamin C in it. So we also look at the fact that the number of colds are recorded in both groups. So it is an experimental study because the independent variable, vitamin C intake, is controlled. The dependent variable, number of colds, is measured, and there is a random assignment, and it eliminates confounding factors. So we're going to work through some of these together. So for the following scores, find value of each expression. So remember, when we have sigma and x, so that would be the sum of all the scores. So we have x right here. Okay. So we would do 4 plus 3 plus 7 plus 1, which would equal 15. So remember, the sum of x, okay? Why is this not erasing? Okay, no erasing. All right, now we have the sum of all the scores squared. So what we have to do, I'm sorry about that. I was looking at the thing. So that would be 3 plus 5 plus 0 plus 2, which would be 10. My apologies. So now we are going to do B, and we need to square each number. So that would be 3 squared, 5 squared, 0 squared, and then 2 squared. 3 times 3 is 9. Oh, did not mean to do that. Sorry about that, guys. That would be 9. 5 times 5 is 25, and 2 times 2 is 4. So now we would do 9 plus 25 plus 4. And that would equal 20. Okay, the brain's not braining right now. 25, 26, 27, 28, 29, 38. I cannot go off the top of my head like that. Sorry about that. Okay. So, now we have this one. So it's the sum of x plus 1. So this is where things start getting a teensy bit complicated, but I promise you it will be okay. How we're going to do this one, I wish I had a button to erase this. Eraser. Alright, there we go. Let's erase this. So we this one. All right. Now we're going to work on C. And the way we would do this is the sum x plus 1. So we first need to add 1 to each number. So 3 plus 1 would equal 4. 5 plus 1 would equal 6. 0 plus 1 would equal 1. And then 2 plus 1 would equal 3. So we're going to add these up together. 4 plus 6 plus 1 plus 3 plus 6, 7, 8, 9, 10. So that would be 14. Okay. That was for D. That was for D. Sorry about that. C would be adding up 3 plus 5 plus 0 plus 2, which would be 10, and then you add 1. So you can see the difference between C and D. Well, I'm glad we made it through chapter 1. If you have any questions or concerns, please feel free to email me. I know this is going to be an amazing term. So again, good morning, good afternoon, good evening,